Now, this is the first video where I think I'm going to bend your brain just a little bit or make you think beyond what you learned in your basic programming classes, where objects are objects and we inherit things and it just magically works and we splash a little bit of pixie dust on there and voila, it's great. No, we need to understand what's happening behind the pixie dust. This is just critical for your long-term existence in game programming. So here I have a class, a base, like we had in the previous video, and derived inherits base. And notice the base has an int, derived has an int. So the size of derived should be 4 plus 4, which makes 8 bytes. You can see right here. So now I'm going to do what we are used to, or something we haven't done is make a member. So void do something, a functional member. And so now, down here in main, when I say base, base instance, then I can say base instance dot do something. And here, let's just trace out which one's being executed. So I can say do something. You know what? That's not right. Let's do. Well, you know what? If I tune this up a little bit, let's say base colon colon do something end line, and the colon colon, get used to it in C++. Again, it's just going down one level of scope, which we're doing here. We're saying base colon colon into do something, which is a nested level of scope. So I'm going to take this do something and I'm going to paste it into derived, but instead I'm going to say derived do something. So now you have the classic base has a method and derived has the same kind of method. And in Java, this just naturally is polymorphic. Meaning if I have a reference, a compile time, well, let me just show you the syntax. This is Java syntax, no longer C++ syntax. But if I say base b gets new base, and I say b dot do something, well, since the compile time type, all the compiler knows in Java, purely Java syntax, let me bring this up a little bit, is that b is of type base. And then when we say new base, here, that's the runtime type. That's what we know at runtime is. B actually references a base instance. And so when I say b.do something, we would expect this line up here to trace because b's runtime type is base. Now if I change that to derived, well, the compile time type, all the compiler really knows is that b is still a base, but the runtime type is derived. It's really this derived instance thing, this 8-byte thing hiding behind a base reference. So when I say b.do something in Java, the virtualness and the overrides automatically take over, and you see derived colon colon do something. Well, in C++ that's not so. In order to make a method virtual, you have to be more explicit than that. So oh, this is bugging me. So let's just say virtual up here. And actually, I need my let's print out the sizes again. Size of derived. Well, let's just do size of base. Inline so the size of base is still 8, I hope. Oh, it's 4. Yeah, of course it's 4. If I say virtual here, well, that turns on the virtualness of do something that you're used to in Java. And if I had the compile time and the runtime types set up again down here in main, when I would call do something on a base reference, and that reference was actually referencing a derived, then yeah, we would see this execute. But I want you to notice something here. I said virtual. Let's just run this. Size of base. Base was 4 bytes, but now it's 8 bytes. And hopefully in your head you're saying, well, where did the additional 4 bytes come from. And what happens is, in order to make virtualness work, this is where the magic and the pixie dust goes away. In order to make the virtualness work, the compiler had to add a pointer, which is a concept we haven't talked about quite yet. But basically, it added a pointer, which is a 4-byte data member, an invisible one to us. It added it to base's class definition. So just be aware of that when you say virtual, all of a sudden 4 bytes more comes on. And don't think that it's really a space issue, because believe me, you can handle 4 bytes here and there, unless you're doing a zillion of things. But it opens another Pandora's box of issues, especially when we write an instance of these types to a disk and read it back in. But we'll get to that later. The main point I wanted to point out here is that when you say virtual, you get an extra 4 bytes, which adds a pointer to the V table, which is talked about in the reading there.